Well, good to see everyone here. Really excited to see such a full room. My name is Nicola Tan. I'm Director of Market Development for Enterprise AI at AMD. And we're going to talk about enterprise infrastructure and agentic AI. I'm sure, unless you've been under a rock in the last couple of months, agentic AI is taking off. And how does that, and why does that impact the infrastructure we need? I mean, national governments, hyperscalers, enterprises have been building for AI since the launch of ChatGPT. But what's really changed is, at the beginning, we were really looking at the chatbot era, an input in, an output out. Those inputs might be complex, and we were doing a lot of prompt engineering and things, but it was a pretty simple input-output model. You know, in late 2024, early 2025, we got the early agentic era, where systems were integrating AI into those enterprise data sets, right? So you had sales agents that were connected to Salesforce. You might have a finance agent that was connected to SAP, support agent that could see all of your JIRA tickets. But these were all standalone systems. They didn't necessarily talk to each other. And mostly it was just a conversational interface to an enterprise system you're already using. Now we've reached this infrastructure time for agentic era, right? So now you have an orchestration LLM, a master LLM that is building out a plan and breaking it down into separate agents that can access different systems. And each of those agents can access dozens of systems within an enterprise. Enterprises have a huge variety of different systems and three-letter acronyms. You have your ERPs and your HRMs and your POSs. I had a list of like 50 different three-letter acronyms, but you get the idea, right? And so like this complexity really impacts the infrastructure that you're going to need to build to manage this, because you're not just trying to optimize for that AI compute. Now you need to optimize for that end-to-end system, including your data and your AI compute. So let's talk about enterprise. The discourse to date around infrastructure has been really focused on hyperscalers. When I talk about hyperscalers, I mean OpenAI or Anthropic, Google, Meta, these massive companies. But what they care about and what your enterprise cares about are very different things, very different use cases. For the hyperscalers, they're in the business of AI. They're delivering AI to millions of people, and generally across maybe a few different core products. So they're optimizing for ChatGPT, for Claude Code, maybe for your Facebook and Instagram feed. And they're delivering this to millions of people at massive, massive scale. Typically, they also have, they already have large structured data sets that they're working with and have really optimized for that end-to-end. These properties are so massive that they can really build a system at the hardware and software level to make that run as efficiently at scale. Enterprises are very different. They're not in the business of AI. Their business is their business. They might be developing products, delivering services, selling goods. Unless you're Allbirds, but that's a different story. So they're using AI to make their business better, to grow their business. So they might be focusing on their employee use of AI. So instead of millions of users, maybe it's hundreds and thousands. But the complexity for them is they have so many different use cases. Every enterprise has HR, marketing, sales, legal, engineering, management. And each of those functions have specialists. Each of those specialists might be doing 10 or 50 or 100 different tasks. So really the variety of tasks that an enterprise needs to and wants to use with AI is expansive. And the other challenge is that their data is everywhere. It's in all of those boxes I showed in the previous slide, very scattered. Today, the hyperscalers are really competing at the model level, right? They are all trying to figure out how do you build the biggest, best, most powerful model. But for enterprises, we pretty much have access to all the same models. Everyone's using OpenAI and Anthropic, or you can use open source models, GPT-OSS or Llama or Qwen. So that's table stakes. The real opportunity for enterprises and their opportunity for differentiation and building value is in their data. And there's different places where that data lives. I was at a roundtable hosted by KPMG a few months back, and they talked about how enterprise IP sits in 3 places. Typically, it's about a third in each bucket. So a third of it sits within sort of industry knowledge. It's the nuts and bolts of how your business works, how your industry works, things you might learn in a classroom or in a textbook, market feed data, different regulations and standards. The second is your corporate data. This is maybe what you're more familiar with, the systems, your corporate databases, your customer data, your employee data, internal documentation, things that are in your knowledge bases. And the third is personal data. This is what's in people's heads. It comes from years of experience in the industry, at your company, in that job. This type of data is sometimes the most powerful, but it's also the hardest to extract. But it comes out. It comes out in meetings and meeting notes, meeting transcripts that we now have much more access to. It comes out in emails and in chats. So given the variety of data within an enterprise, it's not surprising that that data is in multiple places. Some of it's going to sit on your laptop, on your device. Some of it's going to sit on-prem. Some of it's going to sit in the cloud. Even if you're a cloud-first company, you're probably not in one cloud. You're probably in multiple clouds, and you're probably using different SaaS services. Even companies that are heavily on-prem often still have a cloud for bursting into or running different SaaS services. Your devices might be syncing back and forth to different things. So your data, many different places. So with that context, wasn't that surprised when I saw, and I think many of you probably saw this report last year, 95% of enterprise pilots are failing. And it really wasn't the pilots that were failing. What was failing is moving from those pilots to production. Because things work in a sandbox. You kind of take a little, download some data, run an AI on it, and it looks great. But the challenge is okay, now when you actually want to run and scale it, then things break. Because the bottleneck, the challenge wasn't in the AI. The challenge was in the data and accessing the right data. I think as companies really started to anticipate and see the value of AI, they skipped a really critical step. It's really connecting all those different data silos and making sure that they're visible and aware across all the different systems that need to understand what it is. I think many employees here, if you've worked at a big company, you need to go to Salesforce to get one thing. You got to go download a document over here. You go check a database for this, and you have to stitch it all together. So, enterprises, especially larger, older enterprises, it's a lot of work to pull this together. AMD, we saw this ourselves. We're a 57-year-old company, many acquisitions along the way. So we had data in many different places, and we've had to spend the last 12, 18 months building that knowledge graph to stitch it all together to make our AI more effective. So if you're curious how AMD did it, actually our IT team has done a great job really publishing their learnings. So I encourage you to search AMD Advancing IT if you want to learn more. So let's say you've done that, and you've reached AI nirvana within your company, right? You got the data, you can run your models, and now you're getting great agentic systems and outputs. Well, now we're all dealing with the cost of all of that. We're seeing the explosion of token costs, all over the place is the story of the day. An agent typically runs reasoning models. Those reasoning models are now 25x more tokens than your simple chatbot. But that's not the only thing. You just have more users, finding more use cases, doing things more often. Now it's all running autonomously. You need larger context when you're running agentic AI because it needs to hold the context of all the different tools you're calling. So your context sizes are increasing, and that's more computationally expensive. And then these larger models, they're bringing you a lot of great capabilities, but the larger models, very computationally expensive. So those costs all add up. So one way to mitigate that is you don't need the largest models for everything. And you don't have to take my word for that from AMD. NVIDIA's published a paper on this saying this as well. Small models, especially as you break a big problem down into small problems, are very effective in accomplishing some of those tasks. Not only can it do it more efficiently and faster, but it can do it with less hallucinations typically. And that opens up the door for a lot of opportunity to bring things on-prem. Today people are using maybe the largest coding models on Cloud Code. Those run on these massive rack servers, millions of dollars, and more importantly, very, very power hungry and need specific cooling requirements that most enterprises and most enterprise data centers just don't have the capacity to go run today. So they need to go to a third-party service to get that. These small models can run on smaller GPUs that fit into your existing data center infrastructure. So if you're running those smaller models or you're running a variety of models, now you have a choice as to where you're going to run it. You can run it in the cloud, you can run it on-prem, maybe you can even run it on your laptop. And there's a lot of different factors about where you want to place things. You want to think about what's the model that you need to do that job. Now we have tools like the VLLM semantic router that helps you identify what the appropriate model is that you need without having to go to the largest, biggest thing. You got to think about your data locality and figure out, what is your cost of moving that data. That's a big hidden cost, especially for running things in the cloud. Data sensitivity and privacy, what resources you might have. A common model is to run maybe 80 or 90% of your workloads on-prem and burst into the cloud. And what are your latency requirements? If you have the ability to wait a few more seconds, a few more minutes, that makes more sense to run in the cloud or run on-prem. If you need it right away, maybe it makes more sense to run in the cloud. And obviously, policy, governments, rules, and regulations. So unfortunately, there's no one right answer. I think the key as you're building your infrastructure is to build in flexibility. Not everyone needs an AI factory. But my background, my graduate work was actually in manufacturing and operations. So I'm going to build a factory analogy here. You can build a factory that builds a widget super fast and super efficiently. But the reality is, in the real world, you're going to have supply issues, people are going to call off sick, your equipment breaks, the designers change what widget you're making. And so the most successful factories are ones that have been able to build in that resilience and change as needed. Not necessarily the ones that are fast for doing that one thing. And I think that lesson applies here. So AMD, I think we are your best partner for delivering that flexibility, delivering the right solution for the job. If you're not familiar with our portfolio, we have a wide portfolio going from our client CPUs with integrated AI, integrated memory. Our EPYC CPUs are the workhorses of our enterprise IT today. We've got Radeon Pro AI Pro GPUs, which give you the best bang for your buck in TCO. And our Instinct GPUs, which are really the workhorse for mainstream LLMs. And we've put that all together into our Helios racks. That's what's going to run in the cloud. That's running the back end of many of your cloud services today. So AMD, we're there from soup to nuts, end to end, delivering that solution. And I also want to point out that you want to have, as you build your strategy, an open strategy. Open can mean three things. It means open source, delivering transparency and portability in your code, open standards in your hardware and hardware interfaces, and multi-vendor, bringing you choice, resilience. I mean, the same issues on supply in a factory apply here as well. And we've been that partner for deploying open infrastructure for the last 57 years. We've been built on open standards. We work with OCP, x86 ecosystem, UA-Link, UEC. We're built on a strong ecosystem, and we partner very closely with open ISVs, platform providers, model developers. We have portability across models and frameworks through that open ecosystem. So if you are afraid that you need to refactor your code to run an LLM that you ran on NVIDIA onto AMD, if you're using VLM, PyTorch, that is a seamless port over. So you don't have to worry about that because of the work we've put into those frameworks. If you do want to get into custom kernel development, then we have ROCm, and we've got a great suite of tools in that ROCm suite. If you haven't looked at ROCm in the last 6 months, 6 to 12 months, I encourage you to look again. We've made really great progress there. And for folks at upper levels, we've got blueprints to streamline your enterprise AI development so you can download those and get those started real quick. So I'm out of time here, but it was really great talking to everyone here. Happy to talk to folks after the show as well if you're interested for it. Thank you.